In this video, I'd like to introduce amine nomenclature. After watching the video, you should be able to classify amines as primary, secondary, or tertiary. You should be able to classify quaternary ammonium salts as such. You should be able to provide IUPAC accepted names for amines, recognizing when prefixes versus suffixes are appropriate to use. And that's going to be based on functional group priorities. You should be able to provide structures of some of the heterocycles, furan, pyridine, and pyrrolidine. Other heterocyclic structures will be provided. So let's start with the classification of primary, secondary, or tertiary. Primary amines have an alkyl or an aryl group bonded to an NH2. Secondary amines have two aryl or alkyl groups bonded to an NH. Tertiary amines have three alkyl or aryl groups attached. And a quaternary ammonium salt will have four groups attached and therefore a positive charge on the nitrogen, and there will be a counter ion that has a negative charge. You can see from this chart of order of precedence of the functional groups for nomenclature purposes that the amines are a little lower in priority than thiols, alcohols, and aldehydes and ketones, and they're higher in priority than the alkenes, alkynes, and even the imines. When the amine is the highest priority functional group, the suffix will be amine. It can either be named as alkylamine or alkanamine. We'll see examples of both. Let's start with the example of a primary amine that is bonded to a butyl group. So this would either be named as butylamine, all one word, no spaces, or butanamine. Secondary amines are named as substituted primary amines. So I've added a methyl group to the primary amine above. I now have a secondary amine. This is named N-methyl butylamine. If you were breaking this into parts, the N-methyl is a prefix. The butyl is the root, and amine is the suffix. This can also be named as N-methyl butanamine. Here's another example of a secondary amine. This one has a root of benzyl. So this is going to be N-ethyl benzylamine. Note that phenyl would be the C6H5 ring, and benzyl has an extra CH2 added to the phenyl group. Notice that we use an N to specify that the ethyl group is bonded to a nitrogen. So the N is used for a substituent, but it is not used for the root. Here's a more complicated tertiary amine. We're going to number this to give the amine the lowest possible number because it's the highest priority functional group. That amine is on carbon 2, and we're going to have to specify that. We have 3 methyl groups, 2 on the nitrogen and 1 on the alkyl chain. This is named as NN-dimethyl 3-methyl 2-pentanamine. You'll notice that I cannot name this as a trimethyl because we do not combine numbers and nitrogen atoms in the prefix. So this is NN-dimethyl 3-methyl. It is not a trimethyl. Something else that we want to avoid is this cannot be named as a pentyl, and that is because the nitrogen is not bonded to C1. Let's take a look at an example when the amino group is the lower priority group. The nitrogen is going to be named as an amino substituent. Alcohols are higher in priority than amines, so this would be 2-amino cyclohexanol. A commonly encountered diamine is the 1,6-hexane diamine. 6 carbons, and we simply add di as part of the suffix, hexane diamine. This particular compound is often used in the synthesis of the polymer nylon. A commonly encountered aryl amine is aniline. Many of these heterocycles were introduced in the chapter that introduced aromaticity. Heterocycles are cyclic compounds that contain 2 or more elements in the same ring, in other words, carbon and oxygen or carbon and nitrogen. I want to show you the numbering in the heterocyclic compounds that are aromatic, in other words, furan, pyrrole, imidazole, and pyridine. You may encounter substituted heterocycles and wonder how they're numbered, and this is the method. We've already seen pyrrolidine. It is not aromatic, but it is used frequently to make enamines. If you go on and take more biology classes or classes in biochemistry, you'll encounter purines and pyrimidines. They are also aromatic heterocycles, and the substituted purines and pyrimidines make up the nucleosides of DNA and RNA. The numbering of those molecules is shown on the structures. So in this video, I've introduced the nomenclature of amines, and I've also reintroduced the heterocyclic compounds that are aromatic and given you information on how to number those rings.